Well, welcome back to Click for IB Biology. Here we're going to be looking at carbon cycles, the flow of carbon through living systems. We'll take a look at both the long and short cycles and a quick look at some of the information on atmospheric carbon levels that has emerged in the 20th and 21st century. There's a blank version of this presentation down in the description here. That's a PDF that you can annotate, making your own notes as we go. When you've done that and you've viewed the video, you can do the 10 questions which are down there, which also have answers to test your understanding of this particular topic. So the student is required to be able to draw a carbon cycle. Drawing carbon cycles, or sometimes identifying processes, transfer processes and sources of carbon, are often commonly used in the form of multiple choice questions. Since you don't know what the image is that you're going to see in the exam, it's important that you be able to analyze many different carbon cycle diagrams in preparation for this test. When we do that, we should focus on two ideas. One is that there's a source of carbon, and that the carbon in one source, let's call that source A, will be then sent to another source, let's call that B, and that there will be a transfer process associated with getting the carbon from A to B. When we look at the sources, most of them you'll be very familiar with: the atmosphere, oceans, rocks such as limestone, plant biomass, animal biomass. Peat is decomposing plants, carbon locked in the permafrost, and of course the well-known fossil fuels such as oils and natural gases. Now, the way that the carbon moves from one of these sources to another are through these transfer processes here, many of which we study in great detail on this course: respiration, photosynthesis, feeding, decomposition. Combustion is known to us, the burning of fossil fuels and peats. Sedimentation is the formation of in the bottom of rivers as solids settle out and become eventually over time can form rocks. And volcanism is also a process which can be involved in the cycling of carbon dioxide. So my advice is that you recognize the sources and the transfer processes and practice identifying them by looking at a variety of online carbon cycles using my two lists here, which as a way of simulating the kind of questions that you would get in your exam. So the carbon is transferring from one source to another, but we should be aware that there's also a recycling process in the short term through decomposition, in which decomposition in the soils, where dead and decaying organisms are broken down by fungi and bacteria and then are able to be reassimilated into the biomass of plants. A longer term recycling process is in sedimentation, in which carbon structures end up forming rock structures, as we see here. So these limestone cliffs are made of calcium carbonate. So if we look at the formula for calcium carbonate, recognize that in here we have carbon dioxide, and this has become trapped from the shells of the small microorganisms into forming rocks due to sedimentation many millions of years ago. And so the carbon remains locked into these cliffs and is then only released through erosion of the cliffs and particularly the action of acid rains on their surfaces, in which case the carbon dioxide will be returned back to the atmosphere, but this would be a very, very slow process indeed, hence the term long-term recycling. Studies of atmospheric carbon dioxide levels have been carried out from the late 20th century and through into the 21st century, and most notably by Charles David Keeling, here obtaining his Medal for Science 2001, I believe from President Obama. And his work involved working here in Hawaii on the island of Mauna Loa at the observatory on the island, where they sampled the atmospheric carbon dioxide levels, measuring them in parts per million. The data was obtained and then plotted over the decades to give this famous curve here, which is known as the Keeling curve. Within the Keeling curve, characteristically has this zigzag action, which we've drawn larger here, and the reason for the zigzag motion, the up and down motion like this, is because of the seasonality of photosynthesis at low levels in the winter and at higher levels in the summer. The trend that Keeling discovered was an increase in the carbon dioxide levels during this period of time, and using ice cores, this data has been extrapolated much further back in time to show a disturbing increase in the levels of carbon dioxide in the atmosphere. Not that they're exceptional levels over billions of years, but in the terms of the existence of human beings, these carbon dioxide levels are particularly high and have been associated with aspects of climate change, which you will be hearing about in another video series. Charles David Keeling and the Keeling curve. The next video and playlist are showing here, and a chance to subscribe showing your support for the site would be greatly appreciated.